Hi, welcome to lesson 9 in our geometry series. Today we're going to start talking about trigonometric ratio. This is part 1 of our lesson on these. So what it has to do with is the sides of a right triangle are related to the length of said sides are related to the measures of the angles inside. This is when you have an acute triangle. This does not apply to obtuse. So acute triangle there are relationships or patterns between the measure of the angles and the length of the side. This is an acute right triangle. So if you have an acute right triangle, there are some standard relationships. And let's look at a diagram of a right triangle first. There's our right triangle. And we have the hypotenuse. We all know the hypotenuse is that long side. Now, if we have an angle measured, for instance, this angle might be the one that we're referring to, and we might call it theta. So we'll use a lot of Greek symbols in geometry, alpha, theta, and beta. But in this one, we're going to look at theta. That's just a symbol for theta. You can use an X if you want. In relation to theta, only theta, this is the adjacent side. For some reason, sometimes it's difficult to spot the opposite side. So start at the vertex of theta and draw an arrow all the way. There is your opposite side. You've got to get in the habit of that. So here is the opposite. Okay. The way we found the opposite side was we started at the vertex and we drew an arrow straight out. That's the opposite. Adjacent is the one right next to it. Right? Now, if we're looking at the other angle, the one at the top, and let's say the one at the top, we're going to refer to as alpha. Now, if we're talking about the angle alpha, and we want to label the opposite and adjacent side in relation to alpha. To find opposite, you're going to start at the vertex of alpha, and you're going to go straight out across the middle of that triangle, and the one that you cross is the opposite side. So there's our opposite when we're referring to that angle alpha. And the adjacent side is the one next to that angle but not the hypotenuse. You have got to understand those relationships, which side of the triangle is opposite the angle and which side of the triangle is adjacent to the angle that we're referring to. And those sides are different depending on which angle you're looking at, okay? Now, we're also going to look at trigonometric functions called sine, cosine, and tangent. Now, these terms relate from a unit circle and from trigonometry, which you haven't taken yet. You most likely will in college. We have buttons for these on our calculator, though, and we don't need to necessarily understand the full definition of sine, cosine, tangent as it relates to trigonometry and unit circles, but we will use them for these right triangles. So if you look on your calculator, you will see some buttons. You will see the sine, the cosine, and the tangent right on your calculator. Sine, cosine, and tangent. Those three buttons we're going to be using in this exercise, because using those functions and the relationships in right triangles between side lengths and angle measures, we can determine the lengths of those sides. Okay? All right. Now let's go back to our whiteboard, because I need you to commit to memory. When you trip, stub your toe, you have to soak a toe. You have to soak a toe to make it all okay. Soak a toe. Remember that for when you have soak a toe. So, ka, toe. You will look at the words that we just spoke about in the first letter, S, S, C, C, T, T. What do you suppose the O, H, and A stand for? If you guessed hypotenuse and opposite, because we have H and O and A. These come from side length. So sine, cosine, and tangent have special relationships with the measurements of the opposite, adjacent, and hypotenuse, opposite and adjacent sides, and the hypotenuse of right triangles. And they come in trigonometric ratios. So if we're looking at this angle alpha, our first ratio is the sine of alpha equals opposite over hypotenuse. The sine of alpha, whatever the measure of alpha is the opposite over the hypotenuse. That is our first piece of our riddle. SOCA, so the sine equals the opposite over hypotenuse. Sine equals opposite over hypotenuse. Sine equals opposite over hypotenuse. The second piece, or the second ratio, is the CAH. The cosine of alpha equals the adjacent side length over the hypotenuse. Adjacent over hypotenuse. That's where the CAH comes in. So the cosine of alpha is the adjacent over the hypotenuse. See if you can figure out the third ratio on your own. Pause the video, write down an answer, come back, push play, and see if you were correct. Hopefully you figured out that TOA means tangent of alpha equals opposite side length divided by adjacent side length. And that's when we're talking about alpha. So we'll have to put in our alpha. You have to make sure you're looking at the right sides with respect to the angle that you're referring to. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over hypotenuse. So let's put some of those into action. So let's put some of these into action. Let's assume that we have the short leg is 24 of this triangle. The long leg is 70. And the hypotenuse is 74. So we have 24, 70, and 74 for the measurements of our side. So if we're speaking about alpha, the sine of alpha would be what? The sine is the opposite over hypotenuse. So this would be 24 divided by 74. The cosine of alpha would be adjacent over hypotenuse, which would be 70 divided by 74. And the tangent of alpha is going to be opposite over adjacent, which is 24 over 70. So the sine of theta is 24 over 74. The cosine of theta is 70 over 74, and the tangent of alpha would be 24 over 74. You take your side lengths and you can set up those ratios. So now that we're familiar with setting up these ratios, let's do some examples from your worksheet. In this worksheet, you're going to be given the angle and you're going to find a missing side. We're going to be given 36 degrees. And I'm just looking at number 1. So we're given 36. We're given a side length of 12. And another leg is what we're looking for, our x. Now, the first obstacle is figuring out which ratio you need to use. What do you know in relation to the angle? Remember our trick to find the opposite side. Start at your angle vertex and go all the way across the middle so we know the opposite side for sure. We also have the adjacent. This x side is right adjacent to the 36. We do not know the hypotenuse. So we have opposite and we're trying to find adjacent. We need to find a ratio that deals with opposite and adjacent. And that would be the tangent. We don't know anything about the hypotenuse, so we can't use number 1 or number 2. Therefore, we're going to use number 3 because we have opposite and adjacent that we're dealing with in this particular problem. So we're going to have the tangent of 36, because that's the measure of alpha, equals opposite over adjacent, 12 over x. Now remember in basic algebra, when you have a fraction, how do you get rid of that fraction? You multiply it by the denominator. So what we're going to do is we're going to multiply both sides by x. Both sides of the equation, we're going to multiply by x. When we do that, these are going to cancel out. The x's on the right are going to cancel. Anytime you multiply a fraction by the denominator, that denominator goes away. And what it's going to leave us with is x times the tangent of 36 equals 12. Well, what is the tangent of 36? Let's figure that out. We're going to go to our calculator. We're going to use some of those buttons. Tangent 36, enter. I put that last parenthesis in there. So the tangent of 36 is 0.73. Now sometimes we might be tempted to do that. No, that's 36 times the tangent of something. When you're trying to find the tangent of a number, first enter tangent. Now you see you have the parenthesis, 36, closing parenthesis, enter. 0.7, we could just call this 0.73. Now the more numbers you use, the more accurate your answer is going to be. But for this, I look at the choices on number 1, and they're kind of far apart. So I think we're okay if we just use 0.727. Let's do that. 0.727. So the tangent of 36 degrees is 0.727. So we have x times 0.727 equals 12. Now it's just basic algebra. We're going to solve that equation. We're going to divide both sides by that 0.727. And when we do, the ones on the left are going to cancel out. I'll get them in there. So 0.727 on the left, and we have 0.727 on the right. And now we're just going to do that division in our calculator. We're going to do 12 divided by 0.727 and figure out what x is. 12 divided by 7.727. So we're going to clear all this out. 12 divided by 0.727, enter. 16.51 is our final answer. 16.51. And if you look at your answer choices, A is 16.5. That's the one that we would choose. More importantly, look at the measurements of your triangle. Does a side measurement of 16.5 make sense? Yes, it does. This was your longer leg because the longer leg is opposite the bigger angle. 36 is obviously your small angle. This other angle is 54. So the big angle is opposite the big side, so it should be a little bit bigger than 12. 16 is. If we'd have gotten an answer of 150 or something like that, that would have not been reasonable. So you would know that that was not it. So let's look at question number do one with the hypotenuse. I'm scrolling. How about number 19? Let's work number 19. I may just have to leave that line there. So in number 19, we've got the hypotenuse is labeled as x. And we have the leg that's adjacent between the hypotenuse and the right angle. Well, that was dumb. We have the leg, the small angle labeled as 33. And the side right next to that is labeled as 19. So do we know the long leg or the short leg? 33 is the smaller angle because there's 180 degrees total in a triangle. So this angle over here is a little bit bigger. So we know the long leg and we know this angle, and we're looking for the hypotenuse. Look at your 33, the angle that you have labeled. Start an arrow at the vertex and go straight across the middle of your triangle and extend past. There's your opposite side. So we have adjacent and hypotenuse. We need to find a ratio that uses adjacent and hypotenuse, and that's the cosine ratio. So for this one, we have the cosine of 33 is going to equal 19 divided by the hypotenuse, which is x. Let's just go to our calculator and figure out what the cosine of 33 is. Use your cosine button, 33, right parenthesis, enter. So 0.84 0.84 equals 19 over x. Remember, when you have your variable in the denominator, you have to multiply both sides by that variable to cancel it out of the denominator. So we're going to multiply both sides by x. When we do that, the ones on the right are going to cancel out. And we have 0.84x equals 19. We'll divide both sides by this 0.84. And x is going to equal whatever that division is. So we're going to divide both sides by 0.84. And the one on the right, the 8.84s on the left are going to cancel out, leaving us with just the x. So 19 divided by 0.84 on your calculator gives you 22.6. X is 22.6. Look at what you know about the triangle with the side length that you do have labeled. And yes, 22.6 would make sense because that's the hypotenuse. It should be a little bit longer than that long leg. Everything makes sense. All right, you are ready to do this homework worksheet. Remember, you're going to upload a picture of your handwritten note from this video. You're going to upload the work shown. You're going to solve those equations. You're going to write the ratios out, just like we did in the examples. And you're going to put a picture of that with it in number 2. And then you're going to input your multiple choice answers into the Google form. All right, good luck. I'll see you in the next lesson.